Welcome! Today we'll explore how a rocket lands on an asteroid, a feat so challenging that even the smallest mistake could send the spacecraft drifting endlessly into the void. Don't forget to subscribe, like, and enjoy. A rocket drifts silently through the blackness of space, its metallic surface reflecting the faint glow of distant stars. Ahead, a rugged asteroid spins unpredictably, a relic from the early days of the solar system. Unlike a planet or a moon, this rock has almost no gravity, no atmosphere, and no solid ground to land on. It's a hostile world, one where a single wrong move could mean the end of the mission. But the goal is clear: touchdown, secure the spacecraft, and uncover the secrets locked within its ancient surface. Inside the spacecraft, computers work tirelessly, analyzing every shift in the asteroid's movement. The onboard thrusters fire in precise bursts, adjusting the rocket's approach. But there's a problem. The asteroid isn't still. It tumbles chaotically, its surface covered in loose rock and dust that floats in slow motion, disturbed by the rocket's arrival. The challenge isn't just landing, it's staying put. With gravity so weak, even the slightest impact could send the spacecraft bouncing back into space. The landing sequence begins. The engines fire gently, slowing the descent. Harpoons extend, ready to latch onto the surface. A robotic arm reaches out, scanning for a stable point to anchor. The moment of contact is critical. If the timing is wrong, the rocket could tip over or drift away. As the spacecraft nears the asteroid, the tension builds. Then, impact. A cloud of dust rises as the harpoons fire, gripping the rocky terrain. For a moment, nothing happens. Then, the system confirms, landing successful. But this is only the beginning. The asteroid is still moving, and the mission has just begun. What mysteries lie beneath its surface? And how long before the unpredictable environment threatens to undo everything? The spacecraft, a marvel of human engineering, is known as OSIRIS-REx, TREE, an autonomous robotic lander designed to explore one of the oldest objects in our solar system. Unlike a typical spacecraft, this machine has no pilot. Instead, an advanced artificial intelligence guides its every move, making split-second decisions faster than any human could. But even with the most precise calculations, this mission is far from guaranteed to succeed. Back on Earth, mission control is silent, every scientist and engineer watching the monitors with bated breath. A single mistake could mean disaster. The asteroid, named Apophis Prime, is an unpredictable, fast-spinning rock, smaller than a city block yet older than the Earth itself. Scientists believe it holds clues to the origins of the solar system, possibly even the building blocks of life. But first, they must land. The objective is clear: secure a foothold on the asteroid, collect samples, and relay data back to Earth. But there's a catch. Unlike the Moon or Mars, where gravity helps hold spacecraft in place, Apophis Prime's gravity is so weak that landing is more like docking with a moving object in zero gravity. If the harpoons fail, if the engines misfire, or if the asteroid's surface is too unstable, OSIRIS-REx II could bounce off and drift forever into space. The spacecraft inches closer, its sensors scanning every detail of the asteroid's rough, uneven surface. Dust and small rocks hover in the microgravity, shifting unpredictably. Mission control watches as the AI calculates its final approach. The asteroid's motion is erratic, and there's no second chance. Everything depends on perfect execution. The final descent begins. OSIRIS-REx II inches closer to Apophis Prime, its delicate thrusters firing in rapid, precise bursts. Every adjustment is calculated down to the millimeter, a slow-motion ballet between machine and cosmic stone. From millions of miles away, mission. Control watches in absolute silence. The asteroid is far smaller than a planet, its gravity barely noticeable, which means the spacecraft isn't being pulled in. It's simply falling toward it in an eerie, weightless drift. The AI adjusts for the asteroid's chaotic spin, but something is off. The latest scans show the surface is even more unstable than predicted. Loose regolith, fine dust, and small rocks floats around the asteroid, disturbed by unseen forces. Unlike Earth, where dust settles, Here it hovers unpredictably, creating a shifting, swirling cloud around the landing site. This could be a disaster. If the dust obscures the sensors, the lander might miscalculate its descent. If the particles interfere with the harpoon mechanism, the spacecraft may never be able to secure itself. Then, an alert. A sudden spike in velocity. The asteroid's rotation is accelerating slightly, something mission control hadn't anticipated. No one knows why, but the effect is immediate. The AI recalculates, adjusting thrusters in real time, but the margin for error is razor thin. A mistimed maneuver, even by a fraction of a second, could send OSIRIS-REx 2 skimming off the surface and into deep space. Inside the spacecraft, control panels flicker as thousands of calculations run simultaneously. External cameras capture haunting images, jagged cliffs of ancient rock, sharp ridges casting impossibly long shadows against the void. The asteroid isn't smooth. It's fractured and hostile, a graveyard of cosmic collisions frozen in time. The AI scans for the best landing zone, but each second brings new complications. A sudden jolt, a tiny thruster misfire. The spacecraft tilts ever so slightly, barely noticeable, yet potentially catastrophic. The AI corrects, but the approach vector is now slightly off. Mission control holds their breath. At this distance, commands from Earth take minutes to reach the lander and there's no time to wait. The AI must decide: abort, adjust, or risk a dangerous landing. The surface is only a few meters away now. There's no turning back. Through the cameras, the landing site comes into view. A jagged, uneven stretch of rock with deep crevices and shifting dust. The spacecraft is nearly there, but the biggest challenge is yet to come. If the harpoons fail, if the lander doesn't anchor itself properly, the mission will be lost forever. And then, something strange appears on the surface. A shadow. A formation that wasn't in any of the previous scans. Something that shouldn't be there. The countdown to impact begins. 5 seconds. 4. 3. The thrusters fire one last time. 2. 1. Contact. But instead of a smooth landing, something happens that no one expected. The ground shifts. The asteroid moves. And in that instant, the mission takes a terrifying turn. The moment of impact is chaos. OSIRIS-REx 2 touches down, but the surface isn't solid. It shifts like loose sand under the lander's weight. A massive cloud of dust erupts, swallowing the spacecraft in a blinding haze. The harpoons fire, aiming to anchor the lander, but something is wrong. The asteroid's surface is too unstable. The left harpoon strikes a soft patch of regolith and barely holds, while the right one fails to catch at all. The spacecraft tilts dangerously, its delicate balance at the mercy of an unpredictable world. Mission Control watches in horror as new data floods in. The asteroid's rotation isn't just erratic, it's accelerating. But why? Deep space objects don't just change their spin randomly. The AI races through calculations, searching for an answer. Then, an alert. A massive subsurface shift detected. The asteroid isn't a solid rock, it's hollow. And then, the unthinkable happens. A section of the asteroid's surface collapses. Beneath the lander, what looked like solid terrain gives way to a hidden void. The spacecraft sinks, its right side disappearing into the darkness. Mission Control scrambles. If OSIRIS-REx 2 falls too deep, there's no way to recover it. The AI has seconds to react. The thrusters ignite, but the uneven ground makes stabilization nearly impossible. One wrong move, and the entire mission will be lost inside the asteroid's shadowy interior. The AI does something unexpected. It fires the sample arm not to collect material, but to act as a last-second stabilizer, digging into the nearest solid surface. The spacecraft jerks, hanging precariously between stability and disaster. Then, the instruments detect something inside the chasm. Something buried deep within the asteroid. It isn't just loose rock, it's structured. Patterns, shapes, geometry that shouldn't exist here. The mission was meant to collect asteroid dust, but now it has uncovered something far more mysterious. The lander is still slipping. The AI makes one final calculation, knowing it has only a fraction of a second to act. Either it fires the thrusters at full power and risks being thrown back into deep space, or it anchors itself permanently inside. The asteroid sealing its fate, but ensuring Earth gets the data, the decision is made. The thrusters roar to life, a desperate final push against the abyss. For a moment, it looks like the lander will escape. But then, the asteroid shifts again. The decision wasn't enough. OSIRIS-REx 2 is going down. Mission control can only watch as the spacecraft disappears into darkness. The signal flickers. Then, static. The screen goes black. The mission is over. Or is it? The mission reaches its final moments. Whether the landing is triumphant or disastrous, the gravity of the event hits hard. The astronauts, breathing heavily, exchange looks of disbelief or triumph, fully aware that their mission has either rewritten history or ended in failure. But both outcomes are monumental. The landing succeeds. The rocket stabilizes on the Yi asteroid surface with only slight tremors. The crew, though exhausted, exchange quiet words of wonder. They set up their instruments, and the data streaming in reveals something unexpected. A hidden network of strange energy signals or ancient structures, something that shouldn't be there, suggesting a civilization beyond our understanding. What we thought was the end is only the beginning, a question that has now become an enigma, waiting to change everything we knew about space.